Okay, so here is one of these high efficiency machines, and these are the bane of a lot of housewives because they have used these old style machines in the past and they just don't understand these don't use that much water. So when they get a machine like this, they'll look in it and they'll see their clothes and the water's not on top of the clothes, and it drives them absolutely bonkers. And when you have a machine like this and you try to sell it to somebody who hasn't used one before, they don't realize that your clothes do come clean like this. They want the water level to cover it. Now, I think I found a solution for this. I know that you can increase the volume of the pressure hose. I've done that before to increase it. And I've taken a 4-foot piece of pressure hose like this. This one's short. I've taken a 4-foot piece before and been using 1/4-inch barbed adapters. I've lengthened the hose and it increases, in this big old tub it increases a little bit, not that much. So I got to thinking, what if I made a canister, a tunable canister that you can increase the volume of the air? Because the thing is, you need to fool that. There's no way to tune that control board because the pressure sensor is soldered onto that control board. There's no way to tune it electronically. They wish they had put that feature on their control boards, but they haven't. So I'm thinking what you can do, I know that you can increase the volume of the air in the hose, which would fool it. So I'm not sure about the mathematics of it, but I think if you double the volume of the air that it has to do, you would double the volume of the water. But that's not true. It hadn't worked for me. It increases a little bit. So I'm thinking, what if I build a canister that I can tune if I have to for the level of the water, and I need something that I can put inside that case and hide it. So what I came up with, and I did the math, I want to increase the water level in this machine at least 5 times, and I can tune it downward from there, just experimenting. So what I'm going to do is I'm going to build a canister, and I did the math on it, and I'll display it up here. But I'm using a 1.5-inch piece of PVC, and I need a piece 5.5 inches long. And what I'm going to do is put a cap on this end, and I'm going to put this on this end, and I'm going to put these 1/4-inch barbed connectors in this. And I was thinking at first that I could tune it by screwing this in and out, but I'm thinking that there's going to be air leakage by something like this. I'm not sure, but I'll see if I can tune it at all. But what I will do is at first I'm going to make this up, and then may have to make several of them before I get it right. And it may not work at all, but it's an experiment. And this is the drawing that I came up with at first, but this is the parts that the reality are. So I'm going to cut this 5.5 inches, and I will put it together and we'll see how it works. There's a lot of loud noises today. Let's just use this ruler right here. There's a 5.5 right there, and we'll cut it, and we don't need to be precise today. Let's put this in the old vise. Now I hope I can do this. If I do this, I'll make several of these, and I will either sell them to the customer or when I get one of these machines, I'll put them on there, because I tell you, I get more machines that come back to me because of that, because they don't like, and then they go out and buy a new machine, and I'll see them later. I said, how'd that work for you? And they're embarrassed. It's, oh, it works fine. I got plenty of water now. No, they didn't. But they're embarrassed to say that I didn't know what I was talking about when I told them that's just the way the machine is. Alright, let's see if we can cut this without too much trouble. Straight enough. Don't you think? So I'll need to get some PVC glue on one end of this. I hate gluing this up, but I'm afraid if I don't, that it is certainly going to leak air, and that of course won't work at all. Let's see what kind of PVC glue we got here. I hope I got some. Oh Lordy, I'm gonna have to go get some. Here we are. We got our 5.5 inch piece of PVC. We're gonna put this cap on it. We're going to put this on it. Then we're going to drill into the side of it and put our 1/4 inch barbed connectors. And you would know, I can't get the cap off of that thing. PVC glue is pretty good. Just need a little helping hand. Try with a little help from my friends. And this is clear stuff. I hope it's good stuff. And we want to fit it down there as far as we can. Now, we're going to add volume on the bottom. Dry fit. Yeah, let's put some here to make it airtight. Very good. Now, so we got 5.5 inches there, and this is hollow, so we're going to add to it. But as an experiment, I'm making this thing big enough, and what I can do is I can put like drop foam disc or something in there, where I know the volume of it. And I can tune that to where I know how much volume I need to take away from this to make one that's perfect for the washing machine. But now, what I want to do is I'm going to put these, I think I'll tap those. I'll put one on either side here. Put one here and one here. How would that fit in there? It's going to have to fit over in this area somewhere, and then you're going to have to add a piece of hose there. So it's probably better to put one on either side. Let's do that. First, let's see if we have a tap for that. Alright, I want a bunch of taps. There's a fine thread. Oh man, you know, everything I have is hidden. I work with a woman that doesn't have OCD, and she piles stuff on and in and around. Just half this junk is mine. Tappy tap tap. That'd be nice if that was it. I believe that is it. Come on. Let me verify that in the light of day. It is the right. That's the right thread, or the correct thread. Is it the correct diameter? Three-eighths. 24. Fine. I believe it's the right diameter too. How do you get any luckier than that? Alright, so let's find a correct drill bit for this. Too small enough. It's a 3/8, I guarantee. Yep. It probably says so right on the package, Chip. Let's not lose our tap. Get our tap wrench. You know, the reason I am doing this is because I sold a lady one of these machines on Friday. This is Monday morning. And dang, she hadn't called me this weekend and just complained, this thing isn't putting enough water in. I said, well, it's a high efficiency machine. It don't matter. It's supposed to put more water in than that. I said, no, it's not. Yes, it is. I said, I'll tell you what, I'll come Monday and give you your money back. How's that? Well, I need a washer. I said, well, I gave you a washer. Or I sold you a washer. Well, it's not, you know. Yeah, and you can't argue with people. So you just make them happy, give their money back. You'll sell it to somebody else who understands high efficiency machines. But if I make this work, and it's not too costly, next time I sell a high efficiency machine, I'll stick one of these on it. There's that being deceptive. I don't know. I don't know. You opened it up too much enough, Chip. Alright. And we want to turn our laser on. Yeah. And let's put one right there. Now, let's see if the tappy tap tap will tappy tap tap in it. Oh my God. Did I mix that up? I did not. I think it'll self-thread in there anyway. Okay. I don't need to tap that. That tap doesn't work anyway. What I will do is take some of this right here. I've seen a video, or I looked at a thumbnail and they said, "You're not doing that right." Well, how are you supposed to do it? Maybe I'm not. Not putting this stuff on right. I don't know if there's a right or wrong way. I guess there is. If this is wrong, just let me know in the comments. I'm just gonna put enough in there that make it tight. Could have putting some glue on there too. Why don't I do that just to make sure that I get it really good and airtight? Because it leaked down. Got to be real careful. Don't want to get it on those threads though. On the threads on the. There we go. Perfect. Well, I'll do the other one too, so I'll get my glue out. Just take it over there. Alright, so let's cut the other one. We'll cut it about right there. We'll hang on to that now. Sure wants to jump up. And this one we can just like that. Now, we'll take this over here. And this is just an experiment, but I think it's a good idea. We don't want this cap to leak air. So we're going to tighten it on there pretty good. And I don't have a crescent wrench that'll fit that, so I'm going to use this pipe wrench. I don't want to booger it up though. And the more you screw this down, the more it's tight enough. The more volume you're going to lose. Now, what I'll do if I have too much water going in, I'll take this cap off and I'll put foam, something I can measure the volume on. Alright, let me take the back off of this thing. And go with our experiment. Let's hope this works. Now, if I have too much, it'll probably time out and pump out. If I have too much volume. I dropped the screw. But that's why you have spare screws. Chip. I don't know, what do y'all think? Let me know in the comments if this is a good idea or a bad one, or what do you think? I know I can't go too far with that one. And I tell you what, let's just hang it right here for the moment. Just let it hang like that. Yeah, that wouldn't be a bad place to put one of those. Alright, I tell you what, let's crank this rascal up and see how much water goes in it. With that closed, let's do deep water. We'll see if that is way too much volume or if it works at all. It may not work. So see what I'll do. Let me get one of those. Got one? And that's it. That's it. Yeah, that's it. Let me put that in there. And fool it for the lid to be down. And we'll see how much water it puts in. Hopefully it puts in about that much. Alright, let's check in on what this does. If you ever seen a dryer pulley looks like this, you need to change it. It has messed up. This is what a new one looks like, and that is what a defective one looks like. It's worn out. Still got grooves in it from the belt wearing it. It's worn almost down to the threads on the gizmo there. So anyway, this is a new one, this is a bad one. And you can toss it. Wally getting him some love. Wally getting him some love.
Yes, sir. It's a pretty dog.
Wally, leave people alone. Sit. Good boy. Appreciate it, man.
Oh, yes, sir. Anytime.
Now, as far as I can tell, that hadn't put any more water in than it would otherwise. So, but you would think it would. Okay, I've got an idea. What I'm going to do is I'm going to put it on a wash cycle, but I'm going to isolate this part, and I'm going to do it without that little piece of, it looked like weed eater line or something in there. Golly. Without that on, and I'll measure the water level when it goes to washing. I'll measure the water level and we'll see where it comes up to on the tub. Normal one rinse, warm, put on heavy, deep water, and let's give it a start. Now there are no clothes in here to weigh, and the way it weighs it, the way it auto senses, and we don't have it on auto sense, the way it auto senses is it measures the torque. It kind of wets the clothes at first, and it measures the torque and how difficult it is for the motor to turn the basket. And that's how it kind of, they say that's how it weighs the clothes and how much water it needs to put in. But this little thing here says high efficiency. High efficiency means it will wash your clothes with the least amount of water it possibly has to have. So we're going to see. We're going to take a ruler and we'll we'll stop it when it starts washing. When it's in its full wash cycle. And we'll let everything settle down and we'll see how much water it puts in. Alright, so let's see. Yeah, see, it's on this wash cycle. So just let everything settle down, and I'll take the water level readings from the top of that that plastic piece, and it looks like they're right up there on the top of those big, on the bottom of those big holes right there. So if you look at that, it looks like just that 2 inches. Yep, just 2 inches of water in that. So I'm thinking what I do with that. let's attach this device, and we know now that by attaching this device, we're going to have to blow the water out, pinch it off, and then put it in here. Now we can start again. It should start filling with water, and it does. So we know our device is working. How much is it working? Not by much. So the pressure, I bet it didn't. We'll have to have a volume a whole lot greater than that. Looks like it has settled down. Let's see what we got now. Yeah, just about 2 1/4 inches. So it put another 1/4 inch of water in there for that big volume. So we're on the right track, but we need a whole lot more volume of air. If we want it to come way up here, at least to here, so we get a 1/4 inch for the volume that's in there. Ooh, man, we're gonna have a big old tank. I don't know if that's feasible. It sure isn't going to be feasible for a device that you can sell to someone. Those squirrels out there, they cutting up. Yeah, now what I might do next is get a piece of sewer pipe, 4 inches, and we can work with a volume that large. So we do know that increasing the volume of the air in the line increases the water depth. But is it even worth it? 1/4 inch, it's not worth it. Okay. Let's drain it out. So this is day 2 on my little project here, and I just don't want to give up on it. And we figured that the volume of this canister would give us an extra, I think it was a 1/4 inch. An extra 1/4 inch of water in the tank. But so I was thinking maybe if I got some thin wall sewer pipe and a couple of caps and a 1/4 inch. I want to bring that thing up, gosh, to be safe, let's say 7 inches. Let me look at this machine. Where is a machine like that? Here's one. Yeah, if you bring it up 7 inches, I think they'd be pleased with that. 7 inches would bring it up to about right here. And right now it's right here. Probably 8 inches would be better. Yeah, let's say 8 inches. So 8 inches, and we brought it up to there. So 1, 2, 3, 4, 5, 6 times 4. So we need 24 times the volume in this. 24 times that volume. And this is schedule 40. So we can do the math on that and figure out what the volume, how big a piece of pipe we need. So we need 24 times the volume of this, whatever that volume is, and we'll figure that out here directly. But I've thought about, while I was contemplating this, maybe attack this thing a different way. What if we took the pressure transducer and put a potentiometer? That is a potentiometer is a solid state version of a rheostat in line with the pressure transducer. Well, there's 6. This pressure transducer, we have 6 leads. Gosh, get out here in the sunshine, see if we can tell. Usually there's only 3 inputs on this thing, and I think those 3 right there, it's going to be this one, and this one. We could unsolder this, or perhaps we could go online with and figure out which is which, and put a potentiometer. I don't know what these are. Resistors? Maybe a little bitty resistor. That probably smooths out the signal. Yeah, we'll have to have something to smooth out the signal. Or the valve will be going on and off, on and off, on and off every time there's any noise in it. We could attack that electronically by putting a potentiometer between this and whatever circuit on this board needs it to tell the valves to open. I think it's this one. I mean, this part right here. But we're going to have to dive a little deeper into that. I mean, the simple way is to make a canister, as long as it's not that big. But if you put a potentiometer on here where you could adjust it with a screw, or maybe you can't use a rheostat on this thing, but if there's a way to adjust a potentiometer on the console some kind of way, might be pretty neat to do that. Well, that's just an idea for now. We're going to pursue the canister method first. And I've gone to the local lumber supply stores, and they don't have any short pieces of sewer pipe. I think I got some at my house. If I don't, I'll find some somewhere. I got contacts, and I'll make a canister with 24 times the volume of this, which it seems like a lot, but it's probably not. Probably a piece that long of 3.5, 4 inch sewer pipe, 2 caps, and we'll reuse these fittings right here. But that's my idea, and I'll get back to you on that and see when I get all that. I hate to do that, and I need a video for this week, and I might just do this part of it and keep experimenting and keep you up to date on it. That's what I did. At this point, the video is getting kind of long, so I continued it into the next week, and you'll be surprised what happened. Just stay tuned. Tune in next week and see the conclusion to this experiment. Anyway, while I got your attention, my editor says that I have a pretty good following on YouTube, and they want me to plug my books here. I'm an avid author, and I have several books published on Amazon. You can search for Calcashew Books, CALKASHEAU, or you can check the links below. They're all down here in the description. I hope you enjoyed the video. Give me a thumbs up, and I'll see you on the next one.